Hello and welcome to this episode of SPSS one-on-one series with the word analytics. Today we practically build a linear regression model in SPSS. This is part 3 of our series of linear regression analysis. If you've not watched our first videos on linear regression, I strongly recommend you go and check out on them. The links are on your screen. In the first episode, we looked at an overview of all the steps in their right order of how to conduct a linear regression. In our second episode, we tested for the assumptions of linear regression practically in SPSS. So today, we go to the second step of analysis, which is building a model. And in this, there are 3 things we have to do. 1, selecting which variables we shall include in our model, then check for interaction, and then check for confounding before we come up with a final model. So let's get started. We are continuing from where we stopped, and in our last episode, we saw that we checked for assumptions of linear regression using a dataset that comes pre-installed with SPSS, that is the employee dataset. You can access this dataset. There is a link in the description of this video. You can download it. Like I said before, we are continuing from where we ended previously. We checked assumptions. So we have a data set of employees with their characteristics, and our outcome is salary. We want to predict someone's current salary based on a number of characteristics. We had 8 variables that end at gender, but these other variables, the Cox distance, the leverage, and the DF betas, were generated during the process of checking for assumptions. So for now, we do not need them, and I'm just going to highlight those variables that were generated during testing for assumptions, and then I clear them, okay, so that we have our small data set. When building a linear regression model, there are 3 critical steps that you have to follow. Number 1, you have to select the variables that you're going to include into your model. Most of the times you have very many variables and you don't know which one you should choose to include into your model. We shall see that shortly. Secondly, check for interaction. Is there interaction effect among these variables that you are using to predict the outcome? Because eventually that interaction effect would have an effect on the outcome. Then lastly, you check for confounding, whether the variables you're having in your model confound each other or have a confounding effect amongst themselves. So we are going to concentrate on these 2, and we are going to look at them together because they move hand in hand with each other. So that is selecting the variables and then checking for interaction. So the very first thing in building your model is selecting variables. And this selection depends on how big is your sample size. If you have an adequate sample size, a big enough sample size, then include all variables in your model. When we say adequate, usually they take about 40 observations per variable that you're putting into the regression model. But it goes beyond that, not just looking at variables, but you also look at interaction terms. When we talk about interaction terms, we are basically talking about product terms. If I have a variable male, gender, and age, I call those basic variables. But if I want an interaction term between them, I multiply that gender and age. So that product term is what we are calling an interaction term. When you are assessing whether your sample size is adequate, you put into consideration the original variables and the possible interaction terms that you can form. And for each of the variables plus their interaction terms, we should have 40 observations. This is what we mean. In our data set here, we have 8 variables, one of them being the outcome, and the other 7 being independent variables. So altogether, we have 80 variables. We have these 8 variables, the numerical ones, the categorical, and the outcome variable. So when we are talking about adequate sample size, we would have these 8 and their interaction terms. When we are talking about interaction terms, this is what we mean. These interaction terms, they are formed based on whether there is a main exposure or not. How many interaction terms can I have depends on the question that my research is attempting to answer. Give an example. If the question we are attempting to answer is, what are the factors associated with current salary paid to an employee based on this data? We have these variables and we are asking, what are the factors associated with the salary an employee gets? Then in that case, we would say we do not have a main exposure. We are treating all variables as potential factors associated. So in that case, we would have interaction terms amongst all the variables that we want to analyze. So interaction terms are formed amongst the basic variables. So we would form interaction term with the, first of all, with the beginning salary. We form it with education to form this interaction term. We form another beginning salary and job time. I've formed it here. We form one with beginning salary and previous experience. It is here. We form another interaction term with minority here, and we form another one with the gender. It goes here. Then lastly, that variable with job cut, and it is the last one here. We do the same thing to form interaction terms with education and this one here, job time, then education with previous experience, it is here, education with the minority, it is here, education with gender, it is here. We do that for all. In total, you would see that we have a total of, the 7 basic variables, and then we have formed a total of 21 interaction terms, giving us 28. So if we had multiply 28 with the 40 per variable, we would get 1,120. So we would need to have in our data set a total of a sample size of 1,120. Here we only have 474. So our sample size is not adequate. So that is one of the scenarios showing you how many interaction terms are you supposed to form. We've said it depends on whether you have a main exposure or not. We've just seen if you do not have a main exposure variable, that's how you would form interaction terms, and that's what will determine how many interaction terms should you have to determine whether your sample size is adequate or not. Scenario number 2, consider if the question we are asking ourselves is beginning salary associated with current salary paid to employees? At first, we had not fixed it. What are the factors associated with employee salary? But now, we've singled out a factor called is beginning salary associated with the current salary paid to employees. Meaning, it is another way of saying this is what we are focusing on. Others will just come in on board to help in the analysis of this main variable. So if we have a main exposure, it means we are going to form interaction terms with only the main exposure and the basic variables. Then we should form education with this, so it is here. We form with job time, we form with previous experience and the minority up to the end. But we are not forming interaction terms with the other variables that are not main exposures amongst themselves. So we only form interaction terms with the main exposure. If we do have a main exposure, like in this case, we are asking, is there a relationship between beginning salary and the current salary? But we have other factors that we should analyze. So in that case, we would have the 7 basic variables plus only 6 interaction terms, these ones here. Then we have 13, and we would need a sample size of 520. If we go back to our data, we have 474. So sample size still is not adequate. So that's the first procedure. If you have adequate sample size, include all variables. But if you do not have adequate sample size, like how we've just seen, you can use a statistical basis. That is running a bivariate analysis and only take variables that have a p-value less than 0.2. Okay, this is what we mean. So, since we do not have adequate sample size, we are going to our data and run bivariate analysis. That is basically running one variable against the outcome, only 2 variables, the outcome versus the independent variable. Then we look at our overall p-value. So here we would come and say analyze, go to regression, go to linear regression, and then I just want to remove these other variables. Let me just reset this. Our outcome is current salary, the dependent variable, and then we can start with, say, let's start with gender, and then we say okay. If you come and look at our variable gender, our p-value is here, less than 0.001. So that is less than 0.2. So we take that variable, we shall consider that variable for multivariate analysis. We can do that for another variable, analyze, regression, linear regression, and one at a time. So push this back, maybe we can try education level. Okay, then we enter this. We find that the p-value is also less than 0.2. At this stage, we also consider this for multivariate analysis. We are still in the process of selecting which variables to include in our model. Sample size was not adequate, so we are using the statistical approach. So we shall assume all our variables have a p-value less than 0.2, and so they all qualify to go in for multivariate analysis. The other thing to consider when selecting which variables could be based on literature. If, for example, I know that previous experience is a known factor associated with how much someone is paid currently, then I have to maintain that variable regardless of whether it is significant or not, whether I'm violating sample size requirements or not. That variable has to be in my model. That's called logical model building. You're basing on literature to put a variable into the model. Even if it had a p-value above 0.2, we would ensure that we put that variable in. So that's how you select variables to include in your multivariate model. So next we look at how do we check for interaction, how do we form these product terms, and when do we conclude that there is interaction or there is no interaction. So consider liking and subscribing to our channel so that you do not miss out any of our episodes. See you in the next video.